Baik, teman-teman nanti tes bergema, Mister Bang. Tes. Baik, teman-teman nanti setelah saya bacakan yang terakhir sampai English 5.0 ada jeda, bantu tepuk tangan ya. Bapak juga bantu tepuk tangan. Oke? Baik, saya buka dulu ya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Right, good afternoon, ladies and gentlemen, students, committee, and lecturers. Good morning for our keynote speakers from the other part of the world. The Honorable Dean Faculty, the Honorable Head of the International Public Lecture and Practical Workshop 2024, the lecturers, operators, and the students. Welcome to the International Public Lecture and Practical Workshop 2024, Innovative Engineering and Digitalization for the Future of Industry 5.0. All right, ladies and gentlemen, our agenda today will be opening, and then we'll be standing up together singing for national anthem of Indonesia, Ghana, Finland, and India, followed by the welcoming speech of the Dean Faculty of Engineering and Science, UPN Tegal, and then followed by a material workshop by 3 of our speakers. Later, I will read their CV for you, and then Q&A session, taking photo together, and then closing. Right, ladies and gentlemen, we are going to sing national anthem. Please raise for singing national anthem. Ayo berdiri yuk Bapak teman-teman.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा। विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा। तव शुभ नामे जागे तव शुभ आशीष मांगे। गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
God bless our homeland, Ghana, and make our nation great and strong, bold to defend forever the cause of freedom and of right. Fill our hearts with true humility, make us cherish fearless honesty, and help us to resist oppressors' rule with all our will and might forevermore. And help us to resist oppressors' rule with all our will and might forevermore. And might forevermore.
Yes. Ladies and gentlemen, please be seated. Boleh duduk kembali Bapak, Ibu, dan teman-teman. All right, ladies and gentlemen, our next agenda is to hear the welcoming speech from the Dean of Fakultas Teknik dan Komputer Universitas Pancasakti Tegal. Ini tuh Bapak Dr. Agus Wibowo MT, the place is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, respected speakers, distinguished guests, faculty members, and dear students. It is a great honor to welcome you all to the International Public Lecture and Practical Workshop 2024, hosted by FTI UPS Tegal. Here, theme innovative engineering and digitalization for the future of Industry 5.0 reflects our commitment to equipping students with the knowledge and skill to thrive in a rapidly evolving industrial landscape. First and foremost, we would like to extend our heartfelt gratitude and appreciation to our esteemed speakers for their in invaluable contribution to this event. Your expertise and insight are instrumental in inspiring and enriching our academic community. We hope that today's lecture and workshop will provide our students with new perspective, practical knowledge, and innovative ideas that will guide them in their academic and professional journey. This event is also a vital part of our faculty's international development initiative, alongside other activities such as international internship in Japan and in China, summer camps, international public lectures, student exchange programs, and the international music workshop. We continue to strive toward global excellence. On behalf of the organizing committee, and I wish you all a fruitful and enriching experience throughout the program. May this event run smoothly and leave a lasting impact on all participants. Thank you, and I hope you enjoy the day ahead. Wassalamualaikum warahmatullahi wabarakatuh.
All right, thank you for the Dean Faculty of Engineering and Computer Science, Universitas Pancasakti Tegal. Our next agenda is to listen to the workshop of the first keynote speaker. Right, before we start the workshop, here you can see from the screen, we have Pramod Stephen. Hello, are we audible? Okay, we are audible. After this, you need to share screen by yourself. Is that okay?
Yes, of course, I can do it.
Hang on, we are going to make the sound a little bit louder.
Is it okay? Is it clear, loud?
Wait a bit. Test again.
Okay. Is it audible now? Is it better?
Test.
Better? Low? Testing? Testing. I'm able to hear you guys clearly. I'm not sure why.
Please wait a second. The voice here is super echoing. Like then I can help translating to the students. That's why I need to hear this clearly.
Okay.
Okay. The students here we have Mr. Pramod Stephen. His real name is Pramod Plato Tatil Raju, but to make it easier, biar teman-teman gampang menyapanya, teman-teman bisa panggil dia Pramod Stephen. Oke. Kalau kita lihat dari CV-nya, as per CV by Mr. Pramod Stephen, he's really good at the skills of communication, customer service excellence, marketing insight, process optimization. Anyone from informatics department? Ada yang dari teknik informatika udah datang? Yang dari informatika? Oh ya, oke. Maka nanti di bagian Mr. Pramod Stephen inilah teman-teman informatika dan industri. Industrial engineering, Oke, maka kalian harus pay attention because his skill is not only that, but it's also data analysis, time management, software proficiency, project management tools, industri banget ya, project management tools, scheduling, advertising, healthcare. Nah, healthcare di sini akan kita highlight teman-teman dalam artian supply chain kesehatan dan dengan teknologi seperti apa itu bisa dilakukan. Nah, itu yang kita highlight pagi ini. Kira-kira begitu. Oke, Mr. Pramod Steven, the time is yours.
Yes, so you're audible, right? Okay. So my name is Stefan, Promo Stefan, and thank you so much everyone for giving me the time to be here with you guys to share something. And first of all, I want to thank the staff and the faculty members for the time, and Tia for especially inviting me for this meeting. And also thank you guys for the guests to be in this meeting. Um, so I'm going to talk about mostly on the healthcare. So because that's what my background is. So I'm going to share my screen and start my presentation. So just hold on for a moment. I hope guys you can see my screen, right? Hey, I'm so sorry what happens. I'm sorry. I'm back. Just a moment. Okay. So, okay. So as I was saying, then my name is Pramod Stefan, and I'm from India. It's been
Mr. Pramod, can you share screen, please? We still not seeing your screen. I mean, your presentation or anything.
hold on. It's on.
All right. All right. We already make you the co-host. I think you can share screen right now.
Oh, I see. Is it visible now? Is it my screen is visible? Excuse me, is it okay if you can move on to the second one? I think I'm just having a technical issue. I'll just be back within a minute. Is it okay with that?
Okay, I think, I mean, the problem
So,
is you cannot share a screen or
I don't know,
probably,
it keeps on shutting down when I share my screen. So, multiple. Oh, I think I'll try again one more time. If not, then just give to the second one. I'll be back again.
or try
Who is
to
the
turn
next?
off the video before you share screen.
Okay, so I think. So I think what is it? I'll just jump into my laptop maybe because I don't know what happened. So can maybe the next person can join. Maybe I'll do it right after that. I don't know what happened to my system. I'll just try to log into my laptop and see what happens. Is it okay?
How about sending me the file so we can
Okay,
distribute
so
to the students? Okay, you can
yeah,
send to me
yeah, so
directly.
yes, sure. And what is it? Maybe the second someone can present the screen and share. By the time I can send the file to you. Is it okay?
It's okay, it's okay. And if you have the
Yeah.
file, you can send to me and I
Yes,
will
sure.
help
I can send.
the operator.
I can send you. Yeah.
For other speakers, like for example, Emmanuel, sir, are you ready with the material? How about you first? Then we are waiting for Mr. Pramod Stephen as well. Hello, Mr. Emmanuel. Am I audible? Are you audible from here?
Hello?
Yeah, hello. Oh, who is this? Hello,
Hello?
hello. Is this Dr. Tumasi or the?
Yes, please.
Yeah.
Yes, Dr. Chimesi here.
Hello, good morning. We are sorry for the inconvenience. There are problems with the first speakers. Is it okay if you share the screens for your material first? Then we switch the time.
Okay, no problem.
Thank you very much.
Just a minute. Welcome. Just a minute.
Okay, please, sir. The time is
Hello.
yours.
Hello.
Hello, are we able?
Yes, I'm trying to share my screen.
Oh, we already see your screen. This is the first slide. The role of mechanical engineer.
Yeah, hello.
Hello. So is this going to be Mr. Emmanuel or Mr. Tumasi?
This is Chumesi.
Oh, okay. Okay. Now we are looking at Mr. Tuasi slide.
Okay.
It is written UESTC China. Ni hao.
Yes, yes. So hello.
Hello, sir.
Yes, I'm Biden Ejekun Chumesi, hold a PhD in electronic science and technology from UESTC China. I'm currently a senior lecturer at Ho Technical University and in the area of electrical electronics, the head of departments. My research area is mainly antenna designs for various applications together with time reversal electromagnetics. Once again, thanks for the opportunity to be in this workshop. I'm very grateful. Yes, my presentation will initially touch on a little about Ghana. I'll give an introduction about Ghana. In Ghana, we have a political system, and we mainly practice a government type, which is a unitary presidential constitutional democracy, where the president serves as both the head of state and the head of government. We have mainly 16 administrative regions, and we practice a parliamentary system of a unicameral parliament. We have 276 members elected, representing constituencies within Ghana. The major religious composition in Ghana are mainly, we have about 76% Christians, traditional African religion is about 5%, and we have about 19% Islam. Culture. Ghanaians are very welcoming people, and Ghana is a home to over 100 ethnic groups with unique traditions, languages, and customs. The official language of Ghana is English, and some of our local languages are Twiga, Ewe, and Dagbani. Traditional attire, mainly the traditional attire is kente cloth, which is a brightly colored hand-woven fabric, which is a symbol of Ghanaian identity, which is particularly associated with the people of Ashanti region. Cuisine, popular dishes, jollof rice, banku, fufu, wache, and also have spicy stews, soups made with fish, meat, or vegetables. Now to our main business of the day, which is innovative engineering and digitalization. Digitalization for the future of Industry 5.0, the contributions of electrical and electronic engineering. Outline of my presentation is as follows. I will touch on electromagnetic time reversal technique, which has been used over the years for various applications such as tumor imaging, target detection, and hyperthermia in breast tumor treatments. Then I'll look at technological advancements in the field and its relevance to Industry 5.0. Conclusions will be drawn, and then there'll be time for questions.
Oh, yeah. yare a nam pese ne buani sabako.
What is Industry 5.0? Well, Industry 5.0 represents the next phase in industrial evolution, focusing on the collaboration between humans and intelligent systems, such as robotics and AI, to create more personalized, sustainable, and human-centric solutions. Here, robots and smart machines will work alongside with added resilience and sustainability goals included. Now, electromagnetic time reversal, what is it about? Well, this is a technique that is used to realize spatial and selective focusing and has been found to be useful for various applications such as communication, tumor imaging, and hyperthermia breast treatments, as well as target detection. The technique basically depends on the time invariance property of electromagnetic waves, for each forward electromagnetic wave that is propagated, there exists a back spreading or back propagating wave that makes or takes after its kind.
Hello, Mr.
Clutter around, whether there's so much noise, obstacles, reflection, refraction, and diffraction of surfaces up to electromagnetic signals. It doesn't disturb this technique at all. So it is resilient in a very noisy environment. What is EMTRTI? EMTRTI is basically electromagnetic time reversal tumor imaging. And this technique is used to be able to see the inside of the human body non-destructively or non-invasively. Here, personally, I have used this approach to successfully image single tumors and multifocal tumors as small as 2 millimeters in diameter. And these tumors were equally spaced about 2 millimeters or less for various tests conducted numerically. So I have here figure 1. Normally, the process is such that EM waves are sent into a medium where there's no obstacle to learn about the features or the characteristics of the medium. Then the waves are also sent through the medium with the obstacle. The signals are received, recorded, and then time reversed or flipped in time and repropagated back into the medium. And it is found that the waves will focus on the particular medium where the channel sounding was performed or the probing signal was sent in. So this technique uses the back-propagated time reverse EM waves to pinpoint scattering sources, leveraging their distinct dielectric properties. Tumor imaging, yes. On this slide, I have shown a setup for the numerical study that was conducted when I was in China. We have some antennas, both antennas, with some perturbations or scatterers slotted on it with accompanying a scatter structure below or placed below the breast to enhance the scattering effect, to be able to enhance the propagation of what we call evanescent waves, so they can be received in the far field where the antennas are positioned. Below it, we have some imaging results. So this one, we successfully imaged 3 tumors that were spaced close apart, and the time reversal algorithm was used to flip the signal in time and repropagate the signal into the breast medium. Some image reconstruction techniques were also employed to realize clearly visible images of these tumors. Now, some applications of electromagnetic time reversal. We have medical imaging, non-destructive testing, where we use it to test maybe civil structures or some bonded structures that have been bonded to ensure that they are not delaminating or something. And it has also been used for underwater acoustics and sonar applications. And the pioneer in this technique is Matthias Fink and his group. Particularly, it is valuable in scenarios where the medium's complexity makes traditional imaging techniques less effective. Electromagnetic time reversal tumor imaging advantages. It ensures that there is enhanced resolution. Time reversal refocusing enables precise localization of tumors, even in complex and heterogeneous tissues. It is robust to noise, Yes, the method it suppresses noise and interference. So as only the relevant scattering paths contribute to the refocused wave, it is non-invasive. You don't need to invade the medium. So it relies on external measurements, avoiding invasive procedures. Electromagnetic target detection. Well, EM waves or EM target detection is a process of identifying and localizing objects or materials using electromagnetic waves. It leverages the interaction between EM waves and targets to detect, classify, and sometimes characterize objects in a given environment. A typical example is, for instance, buried objects or probably some iron rods in buildings. You want to know exact position of these ones. Electromagnetic time reversal target detection can be applied, and this technology is widely used in defense, medical imaging, geophysical exploration, and other communication applications. Electromagnetic target detection. Here I show some results of two monopole, that is two antennas closely spaced, about 10 millimeter apart. One is radiating at 2.45 gigahertz and the other is 5.2 gigahertz. And it can be seen from this electromagnetic field distribution that the antenna which initially sent the Prupinos channel sounding signal, which was the 5.2 gigahertz, had a stronger field distribution around it. Now we're looking at electromagnetic time reversal in application to hyperthermia, treatment of breast tumors. What is hyperthermia? Basically, it's a therapeutic technique that uses heat to treat cancer. It is able to elevate the temperature of tumor tissues to a range of between 41 degrees Celsius to 45 degrees Celsius. And this temperature enhances the effectiveness of conventional cancer treatment, such as chemotherapy and radiation therapy. So in this work, I try to use transformation structures together with the technique of time reversal to elevate cancerous cells or tumorous cells to some high temperature so they can respond properly to other cancer treatment therapies. Hyperthermia in breast tumor treatment. Well, hyperthermia can sensitize tumor cells to chemotherapy and radiotherapy, whereby it disrupts the cancer immunity cycle and impair oncogenic paths or pathways. Now, near-field focused antenna arrays operating at microfrequencies such as 2.45 gigahertz allow targeted heating of breast tumors without affecting surrounding healthy tissues using the electromagnetic time reversal. At least if there's some heating, it's minimal. Hyperthermia in breast tumor treatment. Combining hyperthermia with emerging therapies like immunotherapy and targeted therapies shows potential for enhanced treatment outcomes. Such combinations aim to exploit the synergistic effect pathway, the way for integrated cancer treatment approaches. Techniques for hyperthermia include external hyperthermia, interstitial hyperthermia, whole body hyperthermia, and then nanotechnology-based approaches, which have been reported by others. Hyperthermia in breast tumor treatment. Clinical applications in breast tumor treatment, such as adjuvant therapy, palliative care, and localized tumor. Now, the technological advancements. Array applicators combined with the differential evolution algorithms. Phase array applicators employ multiple antennas to emit electromagnetic waves into the medium of interest, and this we're able to adjust the amplitude and phase of each antenna to be able to focus energy on the tumor as we want. And it ensures that there will be selective heating, sparing the surrounding tissues, or with minimal hotspots, as we may call it. Now, the differential evolution algorithm is able to optimize and fine-tune parameters like antenna phase and then amplitude. It iteratively evaluates possible configurations to maximize energy delivery to the tumor so that we can have an efficient heating of these tumors. Temperature sensors are also used to provide real-time data on the heating effects on surrounding tissues and tumors. So we use these things to monitor the heating effects. The DE algorithm adjusts settings to ensure consistent target heating. And this advancement enhances specific absorption rates at tumor sites. It also reduces energy deposition in healthy tissues, minimizing hotspot effects. SAR measurements, or SAR, specific absorption rate, measures the rate at which electromagnetic energy is absorbed per unit mass of tissue and is normally expressed in watts per kilogram. It ensures precise energy delivery to the target area. And this is one of the metrics used in the hyperthermia treatment of multifocal tumors using electromagnetic time reversal. It employs real-time temperature sensors and imaging modalities like the MRI feedback into control systems to enable the adjustment of energy delivery dynamically. Predictive modeling. Thermal models. They use the bioheat transfer equation, such as the Penn equation, to predict tissue temperature distribution based on SAR inputs. And simulation tools such as computational techniques are used to model how energy will propagate in different tissue types, optimizing applicator settings. Advances and future trends. Machine learning and AI, algorithms that improve detection accuracy by learning from vast data sets will be employed. Quantum electromagnetics, that is using quantum phenomena to enhance sensitivity and precision in detection applications, will also be of interest to researchers. Then there will also be the miniaturization of sensors, that is development of compact and portable devices for field applications. Multimodal systems, combining different electromagnetic modalities such as radar and LIDAR for comprehensive detection applications. And also low power systems, advances in low power electromagnetic systems for long duration missions such as drones or satellite applications in this medical and target detection applications. What's the relevance of all these applications to Industry 5.0? Electromagnetic time reversal tumor imaging will align with Industry 5.0's focus on personalization by enabling precise patient-specific cancer diagnosis and imaging. And it will also combine human expertise with AI-driven imaging technologies that will improve diagnostic accuracy and efficiency. Hyperthermia for breast tumors. It will enhance precision medicine through personalized automated temperature regulation, leveraging advanced sensors and algorithms. It also will support sustainability goals by reducing energy usage via optimized electromagnetic energy delivery systems. For target detection, it will apply in security, defense, and healthcare, integrating AI and robotics for precise anomaly detections. Then emphasizes human-machine collaboration, the cornerstone of Industry 5.0, is to enhance system effectiveness. In conclusion, electromagnetic time reversal tumor imaging, hyperthermia for breast tumor treatment, and electromagnetic target detection leverages optimization algorithms, phase array systems, and predictive SAR models to enhance precision and personalization in diagnostic and therapy. Industry 5.0, emphasizing human-machine collaboration, AI integration, and sustainability. These advancements reflect shift towards personalized, efficient, and technologically enriching systems in healthcare and beyond. Some references. Thank you.
Big applause, Dr. Tumasi, please. Okay, Dr. Tumasi, please hold on, still in Zoom meeting. Are we sure that our students have some question about your presentation?
Okay.
And mostly coming from civil engineering students, like we don't have electric engineering department, but some of civil engineering students might want to know what is the collaboration between your side and our side. Ayo, teman-teman mahasiswa teknik sipil, ada 2 pertanyaan, boleh? Siapa? Yang mahasiswa sipil ada? Oke, yuk dibaca yuk pertanyaannya. Grup WA-nya dibuka.
Hello, my name is Nisar Al-Arifin. My question is, who is the correlation between electrical design to proper civil engineering design?
Is the how is the correlation between electrical design to proper civil engineering? Since the students noticed about geophysical exploration, we were thinking that maybe it's something related to the place, the building, or specific area or something. That's why this civil engineering student wants to know about it.
Hello?
Hi.
Hello? Hello?
Hello.
Can you repeat the question for me?
Okay. The question is coming from civil engineering students, since we don't have
Civil
any
engineering?
True, since we don't have any study
Okay.
from electrical engineer, but sure, these buildings, this stuff related to civil engineer needs a lot of electrical design. So he was wondering about geophysical exploration. Is it something like we can correlate between electrical design to proper civil engineering design? Like, for example, remote area or specific area or something else?
All right. Thank you very much. Hello, can you hear me?
Yes, you are audible, sir.
Very good. Yes, there's a correlation between these things. For instance, what I have just spoke about, the electromagnetic time reversal technique, it can be used for wireless power transfer applications, where in this wireless power transfer applications, we try to monitor civil structures. For instance, if you have sensors that is monitoring the health of civil structures such as bridges, all right, to be able to report on the health of these bridges, you can use this technique of wireless power transfer, that is electromagnetic time reversal wireless power transfer, to transfer power to the sensors that will be embedded in these civil structures so that they can continuously have power to do the monitoring activities. So there's always a correlation between these things. Yes, one of my research articles, I reported on this, using this electromagnetic time reversal technique to transfer power wirelessly to sensors embedded in concrete structures, all right, which are closely spaced. So in that research, I was able to achieve the wireless power transfer to these sensors, which are closely spaced at 10 millimeter apart. And this was selective wireless power transfer. So there's always a correlation between these things. Now we're looking at smart buildings or buildings being smart. And for that matter, you may have some smart sensors installed, and you can use this technique of electromagnetic time reversal wireless power transfer to supply power requirements to these structures, civil structures. So there's a relationship. Thank you very much.
Noted, sir. Give me some time to translate for them. Oke, teman-teman, tadi pertanyaannya adalah ada nggak hubungannya antara electrical design dengan teknik sipil dan geophysical exploration itu apa? Ya hubungannya ada, bahwa ternyata untuk membuat sebuah struktur bangunan yang di tempat tertentu kayak di remote area atau di gunung atau bahkan mau bikin jalan tol di atas laut segala macam, zaman sekarang orang-orang itu sudah pakai sensor power. Sensor power itulah yang digunakan untuk memetakan daerah mana sih yang bisa pakai struktur bangunan sekian atau daerah mana yang bisa harus pakai struktur bangunan yang lain-lainnya. Nah, struktur bangunannya seperti apa? Tadi beliau mengatakan ada riset beliau, nanti akan kita cari bareng-bareng. Nah, beliau dan risetnya terkait dengan sensor power electrical engineering dengan teknik sipil. Nanti untuk nambah-nambah laporan KKL, teman-teman cari sama beliau, namanya sudah tahu kan, sama cari penelitiannya, paper publish-nya itu ada. Dia ngebahas tentang struktur bangunan dan struktur jalan untuk remote area yang yang dicari tahu apakah baik atau tidak menggunakan electrical sensor. Doctor, so if we search your name on Google and try to find your published paper about this electrical sensor regarding civil engineering building and stuff, we can find it?
Yes, you can find it. It was published in the Journal of Applied Electromagnetics and Computational Engineering Society's
Okay.
Journal. Yes, yes, you can find it on Google.
I think the students enough to type your name on Google, electrical engineering and sensor power, something like that.
Yes, yes.
Okay, noted. Sometime. Jadi teman-teman buat nyari papernya beliau tentang sensor tadi, bagaimana hubungannya dengan kebutuhan bangunan tertentu atau struktur bangunan, teman-teman di Google ketik namanya, yang ini, ketik namanya, lalu ketik sensor power, electric engineering, dan lagi nyatet ya, dan struktur bangunan atau building structure, cari kayak gitu. Nanti akan ketemu, itu akan jadi referensi teman-teman buat nambah-nambah laporan KKL-nya. Oke, satu lagi mahasiswa sipil, ada di rumah? Ada di mana? Ayo, satu lagi mahasiswa, ayo, tolong dibacakan yang water wave installment. Yuk, siapa yang sipil? Kalau nggak ada yang aku pulang, bener. Ayo, satu lagi yang sipil siapa? Oke, yuk, yang water wave installment dibacakan. Right, one more question, sir.
Okay.
Hello, my name is Shahrul. My question, do you have an idea search collaboration with civil engineer, for example, about underwater installment?
Hello?
Hello,
Can you speak a bit louder? I can hardly hear you.
Yeah, I think I have to repeat the question again. Hang on.
Okay.
The question from Shahrul is, do you have any idea of research collaboration with civil engineer, for example, about underwater wave installment? Since they are also building things and technological thing under the water, I think there is correlation between that.
All right, thank you very much. When I was in China, I had some colleague in another university who was working on the area of civil engineering, but I'm not too sure. I think he was doing more of a railway engineering or something. But for underwater acoustics, I think Dr. or Professor Matthias Fink has done some work in that area. But personally, I have not done any work related to that. And also, none of my research teams is working on that.
Noted, sir. Okay, more question. Nanti akan aku perjelas, teman. More question, ada pertanyaan lagi? Tidak ada? Okay, thank you very much, Dr. Tumasi. Thank you very much for the time and for the knowledge. I'm sure the students really excited about reading your paper after this workshop. So don't be surprised if suddenly there are so many downloads of your paper after this.
Thank you very much for the opportunity. Thank you very much to speak to your students. Thanks to the faculty. Thank you.
You are welcome, sir. Big applause for Dr. Tumasi, please. Okay, next is Mr. Pramod Steven regarding informatics engineering. Do you still have problem with the sound?
I think we don't have a problem with the sound. Is it okay if you can share the file from there and I can just say to you to move on to the next slide?
Okay, okay. Now it's
Yeah,
okay.
thank you.
We are going to share screen, and whenever you have to say next, let us know, okay?
Sure, yeah.
Okay.
And sorry for the technical issue, right? We live in the era of technology, so we do have some kind of problem comes up. And sorry about that. Um, so my name is Pramod Stefan, and I live in Finland as past 2 years. I'm originally from
Wait,
India.
wait, Mr. Pramod, please wait. We are having screen problem right now. Please wait.
Okay, sure.
Yes. Okay, Pramod, can you see, Mr. Pramod, can you see the screen right now? It is medical
Yes,
billing.
yes, I can see, yes.
Okay, we are to the next slide.
Okay.
Next.
Yes, you can just move to the next. Okay. So the topic that I brought up on this meeting is on medical billing. You don't really have to be a medical student to work in the medical field. I myself am not a medical billing or I'm not a medical student, but we do have lots and lots of opportunities when it comes to medical billing, as long as there is a human being. Of course, there is lots of work in the medical billing companies. So I was working for the US company, in which we work for the US doctors. We take care of their bills, we take care of the patients. So I'll be going through a little bit of how it works and what are the opportunities that you guys have, even if you don't study in the medical field. So you might be having a question, what is a medical billing? How does it work? And what am I going to do in it? And what are the opportunities available on this field? So when it comes to medical billing, um, in the US, the patients have an insurance. They do have when it comes to the expenses, it's so expensive that if you meet a doctor, you have to spend lots and lots of money. So everyone has an insurance. The insurance company pays to the doctors. So what they do is it's kind of expensive for them to handle each and everything in the States. So they're um, bringing the work to another countries. We do have lots of companies in India, Indonesia. I'm not sure in Indonesia, but in the Philippines and some of the African countries as well as the Asian countries. So they also provide the employment opportunity to everyone. So what is when it comes to what is a medical billing is the process of converting the healthcare system into a bill which is sent to the insurance. And we make sure that the provider, when you say the provider is the doctors or the healthcare system. So we work for the doctors as well as for the hospitals. So we always make sure that the insurance companies pay the right amount to the doctors. So maybe you can move on to the next slide. So as I was saying that who are involved in the process of this. we have the patients. The patients are the one that goes to the doctors and get the treatment and the services, and the healthcare provider, which is the doctors, which provides the services to the patients, and the insurance companies. Insurance company are the one that pays to the healthcare providers, and the medical biller or the coder are the one who takes cares of the medical bills and the the coding and the rest of the stuff. So you can move on to the next slide. Yeah, you can go. We can move on to the next slide. So I just want to show you how does it work. So there is like a pattern or a procedure how does a medical billing works. So you can see the arrow onto your left side where the red one. So when a patient wanted to go to a hospital, it's the same as maybe in your country, but when it comes to European countries or the West Eastern countries, you cannot directly go to a doctor or the hospital. First of all, you have to book an appointment. Only in case of emergency, they'll go to the emergency rooms. Otherwise, if you want to meet a doctor, you'll have to book an appointment to meet the doctors. And once you schedule an appointment, then you go to the hospital and you do a registration. And before, excuse me, before they take you into the hospital staffs will be checking on their insurance eligibility, or do they have insurance. They'll ask the patients, if they don't have the insurance, are you ready to pay the amount what the provider and means the healthcare service is going to render to them. So they will have an agreement. If they say I have an insurance, so they provide the insurance detail to the hospital or the doctor. And if they say they don't have the insurance, they will say I'm responsible for the bill. So this is kind of the circle that goes around. So once the patient reaches the doctor, they do the registrations, and the patient check in, the doctor do the work, they do all kind of work. Then comes the preparing the claim. So what we do is that doctor does just only the treatment. We do all the stuff from the patient registration till the last things. So we do have a different team. So it's in every process have a different team. Um, there are people. There's a recorder in the doctor's room. There is a conversation between the patients and the doctor. So there's a person. There are people who listen to the recording, and they make as a transactions. So they make into like a medical records, and it was sent to the medical coding. So I'll show you another slide maybe in the end, not now, but we all the when it comes to the disease and the diagnosis, it's not written as I have a stomach pain. It's not written as stomach pain, or I have a cut in my hand. It's not written in the medical records as I have a cut in my hand, but it's written all in terms of code. We have like a 5-digit codes, and it can be 4 or 5-digit diagnosis codes. We all play in terms of codes. So coding comes handy when it comes to medical coding. So they do have what subject to study on. They have to study they have to study from head to toe. Like if I have a cut in my finger, there is a code for that. So they have to know each and everything. The patient goes to the hospital, have a meeting with the doctors for 15 minutes. There is a code for that. So if we make any mistake in the code, the insurance company will not pay it. And there is another team who works on it to check each and everything, whether the code is correct. And if it is sent back by the insurance company, we cross verify. We call the insurance company, we ask them what happened with the claim, why we are not getting payment. And they will say the reason this is wrong, something is missing. And another team will work on it, and they make the correction and they send it back. So everything is done electronically. We don't send anything in paper. We have a system, we have a software. The insurance company has software. When we have also a middle like a software that act between the insurance company and the provider's softwares or the medical billing company. So we call as a clearing house for in terms of medical billing. that is the place where it cross-check for the doctors whether we have built everything correctly. If we done something wrong, it will reject and come back to us, and we'll redo the coding or the changes that we had to make, and we'll be sending back to the insurance company, and they recheck everything, and if it is everything correct, they pay to the provider. So this cycles keeps on going and up and down. Like, and at the end, sometimes the insurance company doesn't cover some of the diagnosis or some of the disease. So then the patient is responsible for paying the amount. But we don't charge, like, when it comes to the bill. Sometimes we see the bill. Oh my goodness, the amount is so expensive. So we don't charge the full amount to the patient. Sometimes we charge as 20%, sometimes 20 to 80% that we charge to the patients. So this is how the cycle of medical billing works. So it goes to the patient registration, then they check the financial responsibility, then the patient check in and they check out. Then there's a team who prepares the claim and they check the coding. Once they make a medical reports, the medical reports turn into a codes, and then they submit the claims to the insurance company, and they monitor from their end and see it, and they will generate a statement whether they will be paying the amount or how much they will be paying the amount. Most of the time, the insurance company doesn't pay the full amount. Sometimes they pay the 50% of the amount, sometimes 80%, or sometimes even 20% goes to the patient responsibility. Then we follow up with the patients and ask them if they have another insurance which can cover up those the dues they have. If they don't have, we'll bill to the patients, and if they have, we'll transfer to the another insurance. Can you move on to the next slide? Okay, but as you know that every business or every industry or every line has a problem, right? So the thing is here in the medical billing is that the challenges that we face. The first is the insurance denial. I was talking about that when you send the bill to the, or the claim to the insurance company, most of the time, almost 80% of the time, they'll always deny the claims. They'll always find a silly mistake. Even if I make a silly mistake, they deny it. So almost 80% of the time they keep on denying it. And the next is the error of coding. So sometimes what happened, instead of putting 25 minutes of meeting, they put like 20 minutes. Or I do have a headache, and sometimes they mention something else. So even we have an error in the coding, and then comes up the outstanding out-of-pocket cost, which means the patient has to pay a huge amount of money, which the insurance company doesn't cover. Yeah, so maybe you can move to the next slide, and I'll show you how does a claim form looks like. Maybe the next slide, please. So this is a claim form which I take. One is on the left side is the blank one, and on the right side is the right one. I have marked like a circle things. You can see there. It's the codes which is mentioned there. You don't find anything written as the patient came to the. So 99214 is the code which used for an office visit, which means that the patient has spent 25 minutes in the hospital with the doctors. So this is how it works. So, and the next one is the 8, so I cannot say. So it's like the codes which mention what the patient has, the problem the patient has. So, and we also have the diagnosis code, which is in green color. So diagnosis codes are always with a alphanumeric, and the disease is in numeric form. So then what the insurance company, they also have the list of codes. We do have like, I don't know how much codes we have, but it's in every disease we have, it's in every diagnosis, it's in every sickness that we have a code for. So the coding team work on it. They study. They have a minimum studies of 12 to 18 months. So it depends on how fast you are in grasping up the things. If you can learn things fast, then it takes you an year, or sometimes it takes you 6 months. But you always have to appear for the test for if you want to become a medical coder. Then you are licensed to become a medical coder. Usually, the medical coder receive a high amount of money comparing the people who works the other departments. So coding is kind of uh, much more required and much more wanted in almost in the medical building. But they also require the other process like calling the insurance, filing the claim to the insurance, cross-checking the files, calling the patients and checking things. So we do like they do have. So it's in every cycle they need lots and lots of workers. So there's a huge opportunity if you guys want to work in a medical billing company. You do have a lot and lots of opportunity to work in a medical billing company. So mostly the companies are from US, but the thing is they might have a branch in different countries. I'm not sure if you guys have in Malaysia or in your country, but I'm sure that they do have a collaboration to some of the countries where, because of that, so many jobs has been generated and it becomes and this will be like the future employment opportunities for many people. Yeah, so this is what I want to share, and if you guys have any questions that you wanted to know, maybe I can I'm looking forward to hear some questions from you guys.
All right, thank you very much, Mr. Pramod Steven. I need some time before giving them question sharing session. I need some time to summary in Indonesia for them.
Sure, okay.
Master Bam, tolong share screen yang bulat-bulat. Bagian diagram bulat itu di Zoom coba, Master. Nah, oke teman-teman, untuk mengerti kembali karena tadi Mr. Pranggit ngomongnya cepat juga. Nanti waktu itu teman-teman pakai translation atau minta AI buat lakukan apapun yang teman-teman bisa. Tapi pada intinya adalah ini adalah circle dari medical cycle. Jadi kalau ada pasien di rumah sakit itu pasiennya yang pertama harus check in dulu tuh yang paling pojok tengah, dia harus check in masuk rumah sakit beneran sakit dan beneran dirawat sehingga ada tindakan dan semacamnya. Tapi karena pasiennya tidak bayar, maka pasiennya itu bisa untuk ngeklaim ke asuransi. Nah, di situ itu diperlukan teman-teman di bagian bawahnya, check coding compliance itu kalau bukan orang IT yang paham sistemnya biasanya error karena susahnya nggak ngerti sistem. Tapi kalau yang isinya orang yang tidak paham masalah kesehatan atau dalam hal ini kita bilang healthcare system, ya maka orang IT nggak paham juga apakah harus diabetes atau jantung atau apa atau apa. Nah di sini orang IT-nya di mana, letak orang informatikanya itu ada yang di warna itu, check coding komponen itu, dan di teman-teman inilah yang teman-teman eksplorasi lagi. Sebenarnya tadi itu sudah pakem banget, tapi kok akui tadi indeksnya cepat juga. Jadinya nanti ketika sudah tayang di YouTube, kalian bisa perlahan terus dicatat atau melakukan apapun yang kalian bisa. Oke, oke, Mr. Pramod Steven, we have some questions from the students.
Sure.
Okay, the students want to know if that the coder of the system should be IT person or can be random person.
It can be anyone. It's not really required to be an IT person. So you have to study the coding course, which can last. It depends on how fast the person learn. It can be from 6 months to 18 months, or can be 10 years. So all depends on the person how fast they can learn.
Okay, noted. Give me some time. Oke, tadi aku mengulang pertanyaan, apakah yang decoder itu harus orang IT atau tidak? Jawabannya sebaiknya iya, tapi orang IT yang sudah di-train, orang IT yang sudah diberi pelatihan atau workshop biar dia paham bahwa ada bagian-bagian kesehatan juga yang dia harus paham gitu loh. Tidak mungkin lah misalnya administrator jaringan yang ngertinya mikrotik dan hotspot tiba-tiba disuruh ngisi tentang ritme jantung, itu kan berlebihan sekali ya gitu, kira-kira gitu. Okay, and then the second question is that can you explain a bit about the healthcare chain, the supply chain on of it? Like, is there any correlation between that with supply chain or industrial engineering or something like that?
Yes, I can do that. So how does it work is that, I think every industry they also have the IT field. So we do also have an IT person who works behind the softwares. So anything happen with the software, they are the one who responsible. And when you have a system problem, they are the one who is responsible. So it's not only about healthcare person who is responsible. It can also be an IT person. It can be a normal person who doesn't know anything about the healthcare or the engineering or anything. They can just learn things and they can get into the system. So when I was working in India, we do have like 10 to 15,000 people working in my company. So we also need a number of IT person who take care of our system and our software. So sometimes what happen, we need a new software which can make our work easier. So we'll always look for those kind of developer. So it is kind of open platform. Everyone they can just jump in and try their hands out. And if they feel that if the company feels that they can take in, and then they can just try out the things out there.
Oke, noted. Give me some time to translate for them. Oke, tadi aku berikan pertanyaan ke Pramod Stephen bahwa apakah ada hubungannya dengan teknik industri dan kayak mana juga hubungannya dengan teknik informatika. Jadi berdasarkan pengalaman dia di India sebelum pindah ke Finlandia ini, mereka sempat kocar-kacir perusahaannya karena perusahaan asuransi itu tidak bisa menerima klaim dari rumah sakit karena tidak ada sistem yang membantu supply chain-nya rumah sakit terkait dengan ngeklaim asuransi. Mungkin kalau supply chain-nya rumah sakit terkait pengadaan buat pasien atau apa, mungkin mereka sudah punya sistem yang lebih pakem, tapi kalau yang kaitannya dengan klaim asuransi mereka belum punya. Jadinya yang mereka lakukan adalah perusahaan asuransi itu bikin divisi baru, bikin divisinya itu adalah orang-orang industri yang paham IT. Orang industri inilah yang bikin sistem healthcare-nya, yang bikin sistem informasi ngeklaim asuransi. Kira-kira gitu. Nanti akan aku berikan CV-nya beliau, teman-teman bisa googling nama perusahaannya dan segala macamnya, jadi bisa masukin ke laporan. Nah, lalu setelah orang industri yang paham IT ini bikin sistem informasi asuransi, operatornya siapa? Yang ngelayanin siapa? Ialah orang IT-nya. Jadi orang industri tetap di back end-nya, tetap di belakang, tetap di ngerjain sistemnya aja, eksekusinya antara sistem yang sudah dibuat fresh ini dengan pasien-pasien atau dengan rumah sakitnya itu adalah orang IT-nya. Kenapa nggak orang IT-nya yang di belakang? Karena orang IT-nya tidak terlalu paham supply chain-nya, tapi paham bagaimana sistemnya bekerja. Sampai sini paham? Ya, oke. Oke, thank you very much, Mr. Pramod Stephen. 2 questions is enough. I got thirsty translating for them.
Okay. Yeah, thank you so much for giving me the time, and And thank you, everyone.
Thank you very much. Thank you very much. Big applause for Mr. Pramod Stephen.
Thank you.
Masih lanjut? Masih sanggup? Ada yang butuh ke toilet dulu? Belum. Ada yang butuh. Oke, yuk lanjut yuk. Oke, the last speaker is Mr. Emmanuel Bani. Are you still here, sir? Okay, please welcome the one and only Mr. Emmanuel. Can you please share screen? I think we already make you as a co-host. Yeah. Okay, hello, sir. I think you are still mute. Okay.
Good morning.
Good morning, Engineer Bani.
I don't think we can hear Emmanuel, sir. We already see the screen, but we cannot hear him.
Can you hear me? Hello?
Speak louder.
Can you hear
Engineer,
me?
speak louder a little bit.
Oh yeah, I think you have to put the mic closer to your mouth.
Yes.
Okay, hello, sir. Now you
Can you hear me?
Yes, yes.
Hello? Yes. Hello?
Hello, yes.
Yes, yes. So thank you very much for giving me this opportunity to share my view concerning the innovative engineering and digitalization for the future of Industry 5.0. The role of a mechanical engineer with your students. I am Engineer Emmanuel Manyo Bani, a professional engineer in Ghana and assistant lecturer in Ho Technical University in Ghana. So we are going to look at the understanding of Industry 5.0, the evolving role of mechanical engineer, the traditional design process, the engineering design process, design and fabrication of solar-powered lawn mower, design and fabrication of battery-powered fan spray machines, design and fabrication of convertible metallic public seat, design and fabrication of battery-powered fan spray machines, digitalization in mechanical engineering, design and printing of monuments with the Fab Lab of Ho Technical University, working with other disciplines and challenges, opportunities, project work, and conclusions. So, not to waste my time, I am a specialist in the design and manufacturing engineering. So, when you can hear me, I talk a lot about design and design. So that is my field of specialization. I welcome to today's lecture on innovative engineering and digitalization for the future of Industry 5.0. As we stand on the brink of new industrial revolutions, the role of mechanical engineering has never been more critical, right? This session will explore the transformative changes in manufacturing and design, emphasizing the contributions and responsibilities of mechanical engineers in this evolving landscape. So, understanding of the Industrial 5.0. Industrial 5.0 is characterized by the integration of advanced technology with human-centric approach, focusing on sustainability, collaborations, and personalization. The key components, the human-robot collaborations, and then the emphasizing cooperations between the human and machine to enhance productivity and safety. This has come into the limelight when the COVID came and it has enlightened a lot of people with the human robot collaborations. Then we're talking about the sustainability, we talked about in collaborating eco-friendly practices and circular economy mindset. How we can make our environment eco-friendly and then make use of the circular economy practices around us. The role of a Fab Lab in Industry 5.0. When we talk of the Fab Lab simply means the fabrication laboratory. And a fabrication laboratory or a digital fabrication laboratory is a place to play, to create, to mentor, and to invent, a place for learning and innovations. And as this thing of this public lecture concerning the innovation, the importance of Industry 5.0, I would like us to focus on the Fab Lab. The Fab Lab provides access to the environment, the skills, the material, and the advanced technology to allow anyone, anywhere to make anything in the Fab Lab. So Fab Lab basically is like where students come together with their ideas and then they produce devices, the component of their choice, factoring in the sustainability or the environmental impact of the effect that that device will make on the environment. So the Fab Lab is an ideal, or I would say that is a good place for educators or for learners and even for professionals to come out with their research works. So before we look at the innovations in the engineering, we have to look at the evolving role of mechanical engineer. The mechanical engineer design and then carry out prototyping of his design. Utilization of advanced software tools for simulations and modeling enable rapid prototyping and iterative design process. Integrating of technology, familiarity with Internet of Things, and then AIs and automation challenges and their applications in modern manufacturing systems. Then problem solving and innovations. Applying engineering principles to develop innovative solutions that address complex challenges in manufacturing. So previously, when we talk of design or manufacturing, we are looking at the traditionally how we go about by designing and just making a prototype. But within this era of innovations of technology, we make use of the scientific means in order to make our inventions or innovations unique. Okay, to make our inventions or innovations unique through digitalizations. And this could only be achieved by making use of the Fab Lab. All right. So traditionally, we can design and make prototype before we test and redesign and so on and so forth. And this carries a lot of constraint, a lot of cost. So with the introductions or with the innovations and digitalization, there is a structured or engineering design process. And in the engineering design process, we look at the design needs. Before every innovation, to come out, you need to look at the need for your innovations. The need for your innovation is very important. Then you look at the design definitions, the specifications and requirement of your need to solve your need or your problem of your innovations. Every innovation is being emanated from a need. Okay, so and before you come out with your innovations, you need to collect and informations or relevant informations concerning your design definitions, right? So having done that with your design definitions, then you look at your design conceptualization. So in the design conceptualization, that is where you are looking at how to come out with your innovative ideas in order to augment or to optimize the existing designs, right? So for this, we followed a design process. So from the collective relevant designs and information and visibility studies, then we look at the design conceptualization. At the design conceptualization level, that is where you come up with your ideas, which is more solutions that you think could be visible for your design need based on your design specifications and your requirements. So having evaluated all your design conceptualizations and your design requirement, then you can carry out your design modeling and simulation. That is where we veered into the digitalization of modeling of your design component or your design concept. So for this aspect, the digitalization is more important when it comes to innovations, right? So from there, that is where we make use of the computer-aided tools in the digitalization of our models. So when you are done with that, then we look at the design analysis. The design analysis gives you the room or the space to analyze what you have modeled and simulated, whether it meets your design specifications, whether what you intended, the need that you intended to meet has been met. So having done your analysis, and the analysis could also reveal to you the constraints or the challenges involved. Then from there, you can optimize your design to further meet your
Mr.
design
Emmanuel, can
specifications.
you,
So
maybe
having
it is a wired,
hello,
hello? Maybe
hello,
your earphone is a wire earphone?
hello,
Hello? Yeah, that's
hello.
very clear. Nah,
Yes.
this is better, sir.
Can you hear me?
Yeah, that's a lot better.
Okay.
Yes.
All right.
Thank you.
Thank you. So for your design optimization, that is where when you are done with your design analysis, then you look at the challenges that came out from the analysis, and then it gives you the room to optimize your designs. So having optimized your design, and then to carry out your evaluations or testing of your product. So all these can be done in the fab lab or the fabrications laboratory to give you a manufacturing or fabrication. You can see in HDU, this is a design and fabrication of a solar powered lawn mower, and this is carried out with the mindset that type of mower, and then some we have the electric type of mower. And in this era of fossil fuel or going into a cleaner environment, our students wanted to look at the, the green emissions or the pollution-free environment. So they so you can see over here, this is their fabrications and assemble parts, and finally the solar power. You can see the solar panel on top of it. When we use enhance at least minimize the pollution of the environment from the fossil fuel.
Hello, sir. You are not audible.
Hello,
Huh?
can you hear me?
When you say hello, can you hear me? We can hear very clear, but you
Yes.
like we cannot hear.
Okay. Okay. Sorry. Sorry.
Huh,
So with this, can you hear me now? Can you hear me? Hello?
hello, yeah. So when you say
Yeah,
hello,
okay.
hello in the beginning, it was very loud and clear. I think either you have to talk loud or maintain specific position.
Okay. Can you hear me? Hello?
Yes, sir.
Hello?
Hello, sir. Ah, yeah, this is very clear. Please like this.
Yeah. This is a design project carried out at Technical University where they designed and fabricated a solar powered. Hello? Hello?
Sir,
Hello?
please continue.
Hello? Can you hear me?
Yes, sir.
Okay. So this is the solar powered launch being designed by a group of mechanical students, right? So, and this is carried out in the Fab Lab. That is the entrance of the Fab Lab of Old Technical University. And this is also a design and fabrication of battery powered fan spray machines, whereby the spray machines normally in Ghana, you see people carrying the content of the spray machine at their back, as well as walking through the fans and spray. So with this one, when you are pushing the the machine is being motorized. So the machine is and the motor is powered by battery.
Please, the sound is not clear.
Fuel that you intended. Hello, can you hear me? Can you hear me now?
Your voice is sometimes clear,
Hello?
sometimes not clear, sir. I don't know. Maybe you are wearing a white earphone or maybe internet connection problem.
I think it's internet connection problem.
The way you say, I think this is internet connection problem is very.
Can you hear me now?
Yes, we can hear.
Hello? Hello?
Hello, I think it's okay now.
Can you hear me?
Yeah.
We're looking at the digital twins and simulations, creating virtual models of physical systems, creating physical models of physical designs before implementation.
Ditunggu ya teman-teman, ini dihubungin juga centang satu ini. Berarti mungkin lagi restart internetnya. Okay, please continue, Mr. Emmanuel.
Okay. So digitalization in mechanical engineering, digital twins and simulations, which are also very important, creating virtual models of physical systems, test and um, optimize the design before implementations. All these are embedded in the engineering design processes. Then data analysis, and in the data analysis, we look at leveraging big data for informed decision making, improving efficiency and product quality. So this is also a design and fabrication of convertible metallic fabric seat. So you can see from here the fabric seat is being designed and modeled and then simulated to see the effect of the fabric seat when uh, um, people sit on it. So over here, and this fabric seat can also be converted into a table-like form and stuff, and then be converted back to the seat form for in innovations. It is very important that we work in a team or in collaboration. So you can see over here a robotic team in the Fab Lab of HTU.
All right, maybe Mr. Coffee or Ms. Tomasi, maybe is it like heavy, big raining there that Mr. Emmanuel keep in and out the Zoom? We cannot see him right now. Waduh, lagi seru-serunya teman-teman. Pematirinya hilang dari Zoom.
Okay. Hello. Fab Lab of HTU comprises of electricals and electronic students and design students as well as the mechanical engineering students in the Fab Lab or in the fabrications laboratory trying to work on a robotics. So you can see over here that is a robotic fish being fabricated and then assembled in the Fab Lab. The idea behind this is a fish that could enable the fishermen the fishermen to be able to detect the concentrations of fish under the sea, whereby they won't giving them a signal on their phone whenever they dispatch these robotic fish into the sea to give them the exact locations of where the bunch of the fish can be accumulated. And it also helps in detecting a drone patient, a drone person, somebody who is drawn and they are looking for it. And in Ghana, there are challenges in looking for a drone patient by contracting people, divers, to go inside under the water to look for a drone patient. And this has been a challenge all this while. So this is the idea of designing a robotic fish that could go under the sea in order to look for a drone patient. So when it's able to get in touch with the drone patient, it will send a signal onto your phone that the person is located within this area, as well as where there is a bunch of fish within a location in the sea. It also gives you that signal that there is a bunch of fish over there, whereby you can go there and then carry out your fishing. So this is where the Fab Lab is beneficial in coming out with our designs and applications as far as the Industry 5.0 is concerned. So over here you can see a team comprises of the IT specialists or the IT lecturers, and then the mechanical lecturers, the design lecturers, and then the industrial art lecturers having a training in the Fab Lab of coming out. So collaboration is very important as far as innovations, engineering innovations, and Industry 5.0 is concerned. From the architectural department trying to design and print their own monument. So over here we carry our students through designing of the monument in order to teach them how to carry out the practical aspect from the theoretical aspect to the field. So this is the 3D printer with their monument being printed over here. So this is all something pertaining to digitalization as far as innovations and engineering and digitalization is concerned for the future of Industry 5.0. So you can see the monument that some of the students have designed and fabricated as well as printed. This is also another collaborative work between a mechanical engineering student and then the electronics or electrical student, having designed a smart local energy meter. And this meter sends a signals to the electricity company or whoever that is in charge of the meter whenever somebody wanted to tamper with the meter. So this is basically of a smart way by using the innovative engineering and digitalization to come out with a product of this sort. So looking at the outcome, the challenges, adapting to new technologies, continuous learning and professional development to keep pace with rapid evolving technology, sustainability imperative, addressing environmental concern through innovative design and manufacturing. So this is a project working on to design and fabrication of a tilted feature to hold the engine head for money. So you can see over here a student carrying out a honing process using the drilling machines. So he finds it very difficult in positioning the head, the engine head. So there is a need to design a fixture that will be tilted at a suitable angle to carry out the honing. And this is also assessing the potential of using bamboo sticks and sachet rubber for greenhouse farming in Ghana. We are looking at how we circular economy, how we could recycle all those plastics in Ghana, and how we can make use of the sachet water bottles in carrying out a greenhouse farming. In the greenhouse farming, it is something that is financial costing. It's expensive coming out with a structure, a metallic structure in farming, carrying out greenhouse farming is something that financial burden. So we are looking at how we can make it accessible to small scale farmers, the local farmers in Ghana. So this is also a project being carried out at the Farm Lab, assessing the potential of using bamboo sticks and sachet rubber for greenhouse farming in Ghana. And when we come to the circular economy, and this is also the plastic bottle being packed in the Farm Lab in order to reuse them into a usable material such as the filament or the wax for student practicals. So, in conclusion, the future of Industry 5.0 is an exciting opportunity for mechanical engineers with a new changing landscape by embracing digitalization and sustainable practices. Engineers can play a pivotal role in shaping a more efficient, human-centric, and environmentally conscious industry future. Thank you very much.
Thank you very much, Dr. Emmanuel. Doctor, as long as we sit together, joining your material, one of the students had whispered one question. It is regarding solar panel system.
Okay.
Okay. As we everybody know that solar panel system is heated throughout the sun, from the sun and by the sun. And
Yep.
Indonesia has so much sun the whole year. We always on summer. The problem is not only rich people install solar panel in their house because it is very expensive. Remembering you have to pay for the generator, you have to pay for the panel, you have to pay for other installment, also pay the electrical engineers and stuff. Then you have to have big house to install it on the top of your roof. The problem,
Certainly.
the question from my student is there any way that we as a mechanical engineer student produce a super low cost budget solar panel system? Thank you very much. Nanti tak translate ya setelah dia
Please,
jelas.
I hardly hear you. Hello?
Hello, sir. Yes.
Hello? Yes. I hardly hear you the last end.
Oh, okay. The last question was the student wants to know how to develop a low budget, super cheap solar panel system. Yes. Because in our country, only rich people able to install it.
Okay, okay. So in Ghana, the government is trying so hard in order to look at how they could come out with a low budget solar panels manufacturing that they could use to build solar panels. So I don't know at your end how
Noted, sir. I think the government is also a big roles in order to support the solar
the
panel
government
system
at your
and
end
stuff.
is trying to make a solar panel in Ghana. That is what I can know so far. Hello?
Yes, sir. Hello? So it is really expensive, and then according to you that the local government should be able to support in terms of subsidize the money or something else. Is it like that?
Absolutely, absolutely. And there is also an organization that is also trying hard and liaising with the higher institutions like the universities to come out with a research of coming out with a local material in the manufacturing of solar panels. So I think very soon the solar panels productions will be cheaper in Ghana.
Okay, noted, sir. So I think here also we can conclude that that mechanical engineer should be able to be a politician a bit to, to be able to produce low budget things that civilian can use every day. Alright, give me some time to transfer my students. Yuk, teman-teman, sebelum habis ini coffee break, tadi saya lontarkan pertanyaan, nanti bisa buat
No,
teman-teman.
no. Need to look at the okay.
Give me some time. I need to translate to my students.
Okay.
Tadi sempat saya lontarkan pertanyaan. Tadi kan dia ada ngebahas solar panel kan yang digeret-geret itu kan. Nah, pertanyaannya adalah kalau di Indonesia yang bisa install solar panel itu kan hanya orang-orang kaya. Karena yang pertama dia harus punya rumah tinggi dulu. Terus yang kedua, meskipun kita disinari semrongrongnya matahari itu selalu gitu, cuman kan hanya orang-orang kaya yang bisa install solar panel. Yang pertama rumahnya harus tinggi, yang kedua juga harus install solar panel di atas atap. Yang ketiga harus ada generator juga, enggak boleh barengan sama PLN punya. Takutnya kan nanti tegangan PLN-nya langsung sering jeglek gitu kan, ya apalah bahasa mechanical engineer-nya. Terus harus bayar engineer-nya juga atau tukang listriknya. Terus nanti jadi biaya install di awal tuh mahal banget, bisa sampai 10 jutaan lebih. Walaupun sebenarnya 10 juta itu kalau dipipil-pipil sampai 5 tahun berikutnya enggak bayar listrik versus orang-orang yang ngetengan beli pulsa ya 10 juta juga gitu ujung-ujungnya. Nah tadi aku bertanya bagaimana caranya kita sebagai mechanical engineer bisa bisa menghasilkan panel sistem yang murah. Sehingga kita bisa memastikan bahwa matahari di luar sana itu enggak sia-sia gitu loh, enggak semrongrongnya aja. Ternyata menurut dia solar panel system itu sejauh ini, sedetik hari ini kita sedang duduk bersama di sini memang barang-barangnya mahal. Maka kalau di Ghana bisa jadi murah karena local government-nya. Karena pemerintah lokal itu mensubsidi teman-teman. Nah, maka tadi dia sempat bilang sebagai mechanical engineers, sebagai anak-anak mesin, tidak hanya dituntut untuk mampu membuat prototype, desain, dan apapun yang kalian kerjakan menggunakan Fab Lab dan CAD tadi, tapi kalian juga dituntut untuk mampu berpolitik sedikit-sedikit. Ya, fungsinya ya balik lagi untuk melancarkan barang-barang yang kalian produksi agar beneran bisa dipakai di masyarakat umum. Jadi tidak hanya berhenti di laboratorium kampus aja. Kira-kira gitu. Nah, nanti akan aku berikan slide ini dan CV-nya beliau. Kalau untuk nambah-nambah laporan KKL, dalam CV-nya itu ada paper-paper yang pernah dia publish, nggak jauh-jauh dari solar panel system. Nanti tinggal dicari di Google aja. Masih ada pertanyaan? Biar aku bantu translate. Okay, Emmanuel, sir, I think the students only ask about the solar panel. That's it. Thank you very much for your
Okay.
time.
You're welcome. Thank you for the opportunity given me. I
Sure,
appreciate
sir.
that.
So I will send your slide presentation and CV to the students in case want to read your journal or published paper. They can find out from your CV.
Great, great. Thank you.
Okay, dear keynote speakers, here we have Dr. Tumasi, we have Emmanuel, sir, we have Mr. Kofi, and hi, Mr. Arthur Albert. We've never seen you, but still hi. So this is already the end of our international workshop. We want to take photo together in the form of screenshot. Can you please stop sharing screen and open camera? Emmanuel, sir, can you please stop sharing screen? Okay. And then for there, who is Mr. Arthur Albert? Hello. Can you open camera so we can take photo? Yeah. Okay, screenshot 1, 2, 3. Okay, 1, 2, 3. Okay. Thank you very much, Mr. Coffee. This is my first time looking at you. Thank you very much for your time. It's very early right now in Ghana, right? Thank you very much, Dr. Emmanuel and Dr. Tumasi and Mr. Arthur Albert. Still hello, and Pak Farid also. Thank you very much. Now we will end the Zoom meeting. In case of anything we want to connect again, we can go on WhatsApp. Thank you very much.
Thank you.
All right, thank you very much. Thank you very much.
Teman-teman, sebelum coffee break, kita dengar pengarahan dari Pak Dekan terlebih dahulu.
Ya, baik teman-teman, terima